Hey everyone, and welcome. Have you ever heard the word Kubernetes and just felt your brain immediately cloud over? You hear all these terms, pods, deployments, ingresses, and it's a lot. Well, I get it. Today, we're going to jump in and cut through all that noise, breaking it down one simple building block at a time.
Yeah, that jargon can really trip you up. But honestly, the whole system makes a ton of sense once you really get a grip on the core pieces. So our goal with this explainer is to give you that solid foundation, just breaking down each part in plain, simple English.
So here's the game plan. We're going to start with the absolute basics, and then build our way up piece by piece. We'll look at where your app actually lives, how we make sure it stays running, how we can connect to it, and then how we configure the whole thing smartly. And by the end, you'll see exactly how it all clicks together.
Okay, so let's think about this like we're telling a story, the story of an application. We're going to start with just a single, lonely container, and then we'll see how Kubernetes uses all these different objects to transform it into something that's robust, scalable, and can even heal itself.
Every story needs a beginning, right? And in the world of Kubernetes, that beginning is always the pod. You can think of it as the absolute atom of the Kubernetes universe. It is the most basic, most fundamental piece that we have to work with. And this really says it all. A pod is simply the smallest unit. Now, most of the time, it just holds one single container. You might sometimes see a main container that has a few tiny helper containers alongside it. But the main idea to hold on to is that one-to-one relationship. Probably the best way to picture a pod is to think of it like a little dedicated house built specifically for your application's container. It's not just the container itself, it's the whole environment wrapped around it. This house gives it its own IP address, its own storage, literally everything that one container needs to live and breathe all on its own.
Okay, so we've got a house for our app. That's a great start. But what happens if there's a problem? You see, pods are mortal. They can fail, they get deleted, and if our one and only pod goes down, our entire application just vanishes. That is not very resilient, is it? We need something better.
And that something is the deployment. If a pod is the house, then you can think of a deployment as the property manager. Its entire job is to watch over all the houses, make sure they're in good shape, and if anything goes wrong, it replaces them automatically. This right here is where Kubernetes starts to feel like magic. I love this definition because it's exactly how you should think about it. You don't tell Kubernetes, hey, create a pod, and then, okay, now create another pod. No, instead, you just make a declaration to the deployment. You say, this is the state I want. I want 5 copies of this app, and it's your job to make sure that's always true.
So how does this all work under the hood? Well, when you create a deployment, it actually creates another object called a replica set. The deployment is the brains. It handles the strategy, like how to roll out updates. But the replica set's job is way simpler. It just constantly asks itself, do I have the right number of pods? Nope, I'll create one. Oh, too many? I'll delete one. It's this simple division of labor that gives Kubernetes its incredible self-healing power.
All right, awesome. Our application is now stable, it's resilient, all thanks to our property manager, the deployment. But we have a new problem. Pods can be created and destroyed at any moment, which means their IP addresses are changing all the time. So how in the world does a user, or even another one of our own services, actually find them and talk to them?
This brings us to our next 2 pieces, services and ingress. These are the networking components that solve this exact discoverability problem. They give us a stable, reliable way to connect to our constantly shifting group of pods. Now, it's super important to understand there are 2 very different roles. A service works on the inside. It creates a single, permanent IP address, like a permanent mailing address, that automatically sends traffic to whichever of your pods are currently healthy. An ingress, on the other hand, is the front door for the outside world. It's like a smart receptionist that looks at an incoming URL, like yourapp.com/API, and knows exactly which service to send that request to.
Okay, our app is running and it's accessible. This is fantastic. But what about all its configuration? You know, things like database connection strings or feature flags. It's a really bad practice to just bake those directly into your application's code. We need a way to manage them separately.
And that's exactly where config maps and secrets come in. Now, they look very similar, but they have one absolutely critical difference: sensitivity. You use a config map for all your everyday non-sensitive stuff. But for anything you wouldn't want to post on the internet, passwords, API keys, that kind of thing, you have to use a secret. A secret stores the data encoded in base 64. Now, it's important to know this is not real encryption.
It's more like putting a letter in a slightly blurry envelope instead of a clear one. It provides a little bit of obscurity, but more importantly, it signals to both Kubernetes and to other humans that this data needs to be handled with care.
All right, we've done it. We've assembled all of our building blocks. So let's just take a quick step back and look at the complete system that we've just built, taking our app from just a single container to a fully functional service.
Now, before we do our final summary, there are two last little tools that really help with organization and data. A volume is basically just a disk for your pod. Since pods themselves can come and go, attaching a volume makes sure that any important data can actually survive a restart. And a namespace? It's like a folder system for your cluster. It lets you create these virtual separations for different teams or different environments like dev and prod.
So, there you have it, the whole story, from start to finish. Your application's container gets a home inside a pod. A deployment acts as its manager, making sure the right number of homes always exist. A service provides a stable internal mailing address, while an ingress acts as that public-facing front door. And finally, config maps and secrets neatly tuck away all the settings and sensitive keys safely outside of the application itself.
See? Each of these pieces has a really clear, distinct purpose. And when they all work together, that initial complexity just melts away, and what's left is this incredibly powerful and logical system. So, now that you know the building blocks, the only question is, what are you going to build?